the open interval a b such that integral a to b f c is equal to f of c integral a to b g. Now, since it is given that f is continuous on the interval a b, therefore supremum and infimum of f will exist. Suppose that capital M is the supremum of f on the interval AB. Small m is the infimum of f on the interval AB. Continuity on the interval implies boundedness, so it shows that f lies between its infimum and supremum. Multiply करें on each side of this double inequality with g of x. We get small m into g of x is less or equal to f of x, g of x is, which is less or equal to capital M g of x. Now, since it is given that f is continuous, we know that continuity implies integrability, and it is also given that g is also integrable. So we can take integration on each side of this double inequality. This implies that integral a to b m g of x is less or equal to integral a to b f of x g of x, which is less or equal to integral a to b capital M g of x. Now taking this small m out of integral, we get m integral a to b g of x, which is less or equal to integral a to b f of x g of x, which is less or equal to capital M को बाहर निकालें integral a to b g of x. Since it is given that g is greater than 0, so we can divide on each side of this double inequality. So this implies that m, which is less or equal to integral a to b f of x g of x over integral a to b g of x, which is less or equal to capital M. Now this implies m is less or equal to lambda, which is less or equal to capital M, where lambda is equal to this central term, that is integral a to b f of x g of x divided by integral a to b g of x. Now from intermediate value theorem, we know that if c is any number in between a and b, then we have f of c is equal to lambda because f is continuous. So using intermediate value theorem, we have f of c is equal to lambda. And here we have noticed that lambda is equal to integral a to b f of x and g of x over integral a to b g of x, which is equal to f of c. This implies f of c is equal to integral a to b f of x gx over integral a to b g of x. So cross multiply करें, so get the required result, that is integral a to b f of x gx is equal to f of c integral a to b g of x. This completes the proof of generalized mean value theorem. Our next theorem is that f and g with the antiderivatives of small f and g respectively, also f and small f and g are Dawberg's integrable on the interval ab, and we have to prove that integral a to b capital F of x, ये small g है. This is small g of x. This is small g of x dx. Integral a to b capital F of x, g of x, which is equal to capital F of B, capital G of B, minus capital F of A, capital G of A, minus integral A to B, F of X, capital G of X, dx. So we have to prove this. Since it is given that capital F and G are antiderivatives of F and G respectively, so using the definition of antiderivatives, we have F dash of X is equal to F of X and G dash of X is equal to G of X. This is using the definition of antiderivatives. Now using the product rule from differentiation, we have d by dx x, which is equal to f dash of x plus so this implies f dash किसके बराबर है, इसके बराबर है, और g dash किसके बराबर है, इसके बराबर. So we get f of x plus g of x. Now if we take integral on each side, both sides of ठीक हो गए, हमने इंटीग्रल ले लिया बोथ साइड्स. नाउ इस पर इंटीग्रेशन अप्लाई करें तो हमारे पास ये डेरिवेटिव और इंटीग्रल एक दूसरे के रिवर्स प्रोसेस. सो वी गेट b to a of x. ठीक हो गया. नाउ अगर अब लिमिट पुट करें तो वी गेट a which is equal to plus अब इस टर्म को इस साइड पे रहने दो, दूसरे को इधर मूव कर ले. वी गेट x is equal to minus this completes the proof of this theorem. Now, if capital F and G are antiderivatives of f and g respectively. Also, if f and g are Dolbeck's integrable on AB, then we have to prove that integral a to b capital F of x small g of x dx is equal to capital F of b g of b minus capital F of a g of a minus integral a to b f of x g of x dx. Now, since it is given that capital F and capital G are the antiderivatives of f and g respectively, then this using the definition of antiderivative, we have capital F dash of x is equal to f of x and capital G dash of x is equal to small g of x. Now, using the product rule of differentiation, we have d by dx, capital F of x, capital G of x is equal to f dash x first function का derivative into second function plus first function को ऐसे रखें और second function का derivative. Since it is given that capital F dash of x is equal to small f of x and capital G dash of x is equal to small g of x. Now taking integral on both sides of this equality, we have integral a to b d by dx capital F of x g of x is equal to integral a to b f of x g of x plus integral a to b capital F of x g of x. इंटीग्रेशन अप्लाई करें, रिवर्स प्रोसेस है, we get f of x g of x limits upper limit b lower limit a equal to integral a to b f of x g of x plus integral a to b capital F of x g of x. लिमिट अप्लाई करें, capital F of b g of b minus f of a g of a is equal to integral a to b f of x g of x plus integral a to b capital F of x g of x. इसको इसी साइड पे रहने दें, इसको दूसरी साइड पे मूव करा लें, तो we get integral a to b capital F of x gx is equal to f of b g of b minus f of a g of a minus integral a to b f of x capital G of x. So this completes the proof. एक मर्तबा मैं सारी स्लाइड्स दोबारा आपके सामने चला देता हूँ, किसी को कुछ मिसिंग हो गया हो तो वो दोबारा नोट कर लें. मिनकॉस्की इनइक्वालिटी से हमने स्टार्ट किए थे. होल्डर्स इनइक्वालिटी जो हमने लास्ट लेक्चर्स में किए थे प्रूफ, उसको यूज किया मिनकॉस्की इनइक्वालिटी को प्रूफ करने में. This was our second result. Is continuous and non-negative. Integral a to b f of x dx तब ही जीरो होगा जब f of x is equal to 0 होगा. f of x is not equal to 0, इंटीग्रल भी हमारे पास not equal to 0 होगा. This was an important result of today's discussion, that is generalized mean value theorem. Here we have used intermediate value theorem from the analysis 1, or we have also studied it in calculus as well. Since it is given that function is continuous, so for any c in the interval, open interval AB, we have f of c is equal to lambda. This is our supporting result, which will be used in the next theorem. F and G are antiderivatives. We have this. Our next theorem, another important result of today's discussion, is Weierstrass form of mean value theorem. This is our next result, one of the important results of today's discussion, that is Weierstrass form of mean value theorem. जी ये क्या कहता है कि let f be a differentiable function on the open interval AB and let f dash be a Dolbox integrable on the closed interval AB. Further, if g is a continuous function on the interval AB, then there exists a point C in the open interval AB such that integral a to b fg is equal to f of a integral a to cg plus f of b integral c to b g. ये हमने प्रूव किया. Now, since it is given that g is continuous on the interval AB, and we know that continuity implies Dolbox integrability. So we have integral a to suppose हम ये suppose करें let a to integral a to x g dx is equal to g of x. Number one. Also suppose that g of a is equal to 0. Number 2. दो supposition हमने ले ली. First, integral a to x g dx is equal to g of x, and second, g of a is equal to 0. Now this implies d by dx integral a to x g dx is equal to d by dx g of x. This implies g upper limit is x and the lower limit is a, which is equal to g dash of x. And this is g of x minus g of a is equal to g dash of x. This implies g of a is equal to 0, g of x is equal to g dash of x. So it is number 3. Now, integral a to b f of x g of x dx will be equal to integral a to b f of x g dash of x dx. Okay, go. Now using previous theorem, we have integral a to b f of x. यहाँ पर हमने previous theorem को इस्तेमाल किया, which is equal to f of b g of b minus f of a g of a minus integral a to b f dash of x g of x dx. ठीक हो? This is by using the previous theorem जो भी हमने प्रूव किया. Now this implies integral a to b dx will be equal to g of a is equal to 0, so this term will be cancelled. A to b dx. ठीक हो गए? Now, using generalized mean value theorem, we can write integral a to b f of x g of x dx is equal to f of b g of b minus g of c a to b f dash of x dx, where c lies between interval a b. This step पर हम using mean value generalized mean value theorem जो भी हमने प्रूव किया. Now this is equal to f of b g of b minus g of c f of x b a. This implies this is equal to f of b g of b minus g of c f of b minus f of a. Multiply कर दें, you get f of b g of b minus f of b g of c माइनस माइनस प्लस हो जाएगा f of a g of c. इन दो टर्म्स में से f of b कॉमन ले लें, you get f of b g of b minus g of c plus f of a g of c. इसको आप कह रहे हैं नंबर 4. This is minus. This is equation number 4. Now f of a to c g plus f of b c to b g is equal to f of a to c g dash plus f of b c to b g dash। क्या मैं इस तरह लिख सकता हूँ इसको? जी, एनीवन? Can I write f of a to c small g plus f of b c to b small g is equal to f of a integral a to c g dash plus f of b integral c to b g dash? Can I write?
Yes, sir.
Anyone?
Yes, sir.
Yes. जी कैसे?
सर प्रीवियस उसमें हम वो प्रूव करके आए हैं पीछे के जी इज इक्वल टू जी प्राइम।
जी 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 बिल्कुल बिल्कुल ठीक है। From equation 3 we have g dash is equal to g. Now this implies f of a to c g plus f of b c to b g is equal to f of a g c to b। लिमिट अप्लाई करें प्लस और मल्टीप्लाई करें वी हैव प्लस माइनस सी कैंसिल हो गया। g ऑफ a इज इक्वल टू 0 है। इन दोनों में से f ऑफ b कॉमन ले लें, वी गेट f of a to c g plus f of b c to b g is equal to f of a g of c plus f of b g of b minus g of c। ठीक हो गया? अच्छा ये किसके बराबर है? From equation 4 we have this is equal to integral a to b f of x g of, so this implies integral a to b f of x is equal to g plus this completes the proof of our theorem, that is Bayes transform of mean value theorem। इसका डिटेल से हम दोबारा प्रूफ नेक्स्ट लेक्चर में इंशाल्लाह देखेंगे।